Now we need to look at more complex plumes. Complex plumes are ones where the smoke does not rise directly from the fire into the smoke reservoir above, but where the smoke rises to meet a ceiling away from the smoke reservoir and then travels horizontally beneath that ceiling for some distance, possibly encountering obstacles en route, before spilling upwards into a smoke reservoir that is remote from the location of the fire. Typically in the UK, complex plumes are found in many shopping malls where the fire would start in a shop unit and then smoke would leave the shop unit into the mall, either spilling directly into the smoke reservoir at the top of the mall or travelling beneath a balcony or other feature of the building before reaching a spill edge and spilling up into the reservoir. Any fire located in the atrium itself, directly beneath the smoke reservoir, will produce a simple plume that rises directly into the smoke layer, so any such fire should be dealt with as described in the simple plume section. As in shopping malls, open spatial planning in offices, which means the presence of openings between separate levels and not just open plan offices on the horizontal, can also give rise to situations where smoke will have to travel horizontally for some distance before spilling up into a smoke reservoir that is typically located at the head of an atrium. In the complex plume scenario, there are a number of calculations that we must make in order to establish the maximum amount of smoke that may be entering the smoke layer. First of all, it must be made quite clear that it is not usually the objective of the smoke and heat exhaust ventilation system, the SHEVs as it's known, to protect the means of escape in the room of fire origin. These means of escape are usually taken care of by the traditional means of limiting travel distances, providing alternative escape routes and protecting staircases. The objective of the SHEVs is to protect people in parts of the building other than the room of origin. Having said that, there are cases where the SHEVs is required to protect means of escape in the room of fire origin, but this will only happen in large rooms and spaces, such as large anchor stores off of shopping malls or large assembly buildings such as cinema foyers or bowling alleys, or indeed in the warehouses and factories that we were looking at when we were examining the simple plume. We'll proceed on the assumption that the room of fire origin has means of escape that are kept safe by more traditional methods, and that a SHEVs is required to protect people elsewhere in the building. Before we can calculate the amount of smoke that is entering the smoke layer in the reservoir, we have to know how much smoke is entering the spill plume at its base. And to know how much smoke is entering the smoke plume at its base, we have to know how much smoke is leaving the room of fire origin. We need to calculate the mass flow rate of smoke leaving the room of fire origin. Secondly, we take into account any added entrainment that takes place as it encounters obstacles, such as downstands. And finally, we determine the entrainment as the plume spills into and ascends through the atrium.